Chemical reactions usually are classified as redox and non-redox. What is redox reaction? I'm not gonna explain redox in this level of chemistry, but just know the definition. It means that in redox reaction, we have is a combination of reduction and oxidation. It means that electrons are transferred from one element to another element. So in redox reaction, electrons are transferred from one element to another element. This is called redox reaction. Redox reactions they have also some subcategories: combination, single replacement or substitution, and decomposition. Also, we have non-redox reactions. In non-redox, we don't have redox. So we do not have transfer of electrons from one element to another element. In them, we have also combination, double displacement, and decomposition reaction. Before I continue, I want to talk about where those states are coming from. And then we continue with the rest of the chemical reactions. Okay, guys, I will provide this table to you in the exam for now, but make sure you know how to read it. What does it mean? This is called solubility rules table. What is called solubility rules table? In this table is used to see if the state of the compound is solid or aqueous. So this table is used if the compound is solid or aqueous in water, basically. So if you remember, we said that aqueous means the solvent is water, right? So if the compound is not soluble in water, we put S as solid in right side of the compound. If is soluble in water, we put AQ, or in the right side in the parentheses of the compound. In the parentheses in the right side of the compound. Whenever you have a compound that has Li plus, or maybe, to make it easier, group 1A elements and ammonium, which is from the polyatomic ion table, is always soluble. So you always put AQ in the right side of that compound. For example, if you have LiCl, you put always AQ in the right side of the LiCl. If you have, for example, NaBr, you always put AQ in the right side because it's always is soluble in water. Okay, as you see in the top of it, it says these compounds, which have these ions, are mostly soluble in water, basically. So this solvent here is water. Also, when you have a nitrate or acetate, is always soluble in water. So when you see, for example, NaNO3, you always put AQ in the right side of it. For example, if you see a compound that has an acetate, always put aqueous. What about the halides or halogens here? The halides that have, let's look at here. All of the halides are soluble except when they pair up with Ag plus, mercury, or Pb2 plus, then it's gonna be insoluble, or you put S in the right side of it. For example, PbCl2 is solid, or Hg2Br2 is solid, or S in parentheses in the right side of the compound. AgCl is solid. What about sulfate? All sulfates are soluble except when they pair up with these ions. For example, CaSO4 is solid. SrSO4 is solid. But, for example, Na2SO4 is aqueous. Okay, so if you don't see Ca2 plus, Sr2 plus, Ba2 plus, or Pb2 plus combined with sulfate, is solid. If it's not paired with this, if your compound is not one of these, it means is not one of these, is soluble. What about this? These compounds that have these ions are mostly soluble, or mostly insoluble, except this. For example, hydroxide. So hydroxide is from the polyatomic ion. And sulfide are insoluble, or you put solid, unless group 1A element or ammonium. We said that here, guys. It's repeat. We said that if you have Li plus, Na plus, K plus, and ammonium plus in the compound, is always soluble. It's repeating here. But here, when you have a sulfate paired with calcium, Sr2 plus, Bi2 plus, and basically these ions that you see here is gonna be soluble. Okay, it's gonna be soluble. When OH minus paired with these ions, is gonna be soluble. When you see a slightly soluble, please put aqueous. I accept it. Okay. Carbonate and phosphate are insoluble except when they pair up with this. Okay, so oxides, I just added them up because are kind of usually we have oxides in the compound and is confusing for the students. Oxides are usually insoluble, or you put S, except if you have Na2O, K2O, SRO, BaO are soluble, and CaO are slightly insoluble. So when you see a slightly, also put aqueous. Okay. Okay, let's see if these are soluble or insoluble. PbNO3 2, what do you think? It has a nitrate, right? So all the nitrates are soluble, right? All the nitrates. So you're gonna look at this table and find out. I'm gonna provide this table in the exam for now. Okay, so all the nitrates are soluble. So this is gonna be aqueous. So I'm gonna put AQ next to it. Okay, so what about PbSO4? All the sulfates are soluble when they pair up this. Oh, here, Pb, if it's pair up with Pb, is gonna be insoluble. So I'm gonna put here what? What do you think, guys? Solid. I'm gonna put S here. So make sure go back to this table and From this table, realize which are soluble or not. What about sulfites? So look at this anion or the right element, or basically the anion always we said are in the right side, right? So look at this and then go to a table and see which of them are gonna be soluble or not. So it's with copper, right? So it said are mostly insoluble, but if they pair up with these are gonna be soluble. Here is CuS. What do you think? It's gonna be insoluble. So I'm gonna put here CuS is solid because our sulfides are insoluble except this. You do not see Cu here, so it's gonna be solid. What about PbCO3? So let's go to carbonate. All of them are insoluble except this. So Pb is not one of those, right? So it's gonna be solid. What about NH4Cl? All of them are soluble, right? All of the group 1A element and NH4Cl and nitrates. So I'm gonna put aqueous. So from this table, you basically realize aqueous and solid. You might ask, okay, what about liquid and gas? How I should find it? I will basically tell you later, but for now, just know when you see H2O or water, always is going to be a small L or liquid, okay? Unless they tell you is something else, okay? So when you see water or H2O, always assume is L or liquid and write L small next to it, unless they specify that is gas or something else. For gases or G, we know already the 7 diatomic elements are already basically most of them are gas. Okay. Also, CO2, carbon dioxide, we know is gas, you know. CO or carbon monoxide is gas. Some of them are kind of obvious that is gas. I'm not gonna give you more than these in the exam, guys. More than these that I told you in the exam about gases and liquid. But make sure you know how to use this solubility rule table in the exam. Again, I'm gonna provide this in this table in the exam. Okay, guys, let's talk about the redox again. We said that the redox is the combination of reduction and oxidation, and it means that electron transfer from one element to another element. Another meaning, one element losing electron or becomes oxidized and have oxidation, and one element gain the same electron that the other element lost, and it becomes reduced or reduction happen here. Okay, just know this much, guys. I'm not gonna ask about which of these are redox. Okay, so just know the meaning. Another type of reaction is decomposition reaction. For example, here HI breaks to H2 and I2. So one compound becomes two compounds. This is decomposition reaction. Combination reaction or synthesis is opposite to decomposition. Two compounds becomes one compound. For example, the two carrots that you broke them to half, you're gonna glue them together. So two compounds become one compound. The example here is sulfur and oxygen. basically give us SO2. That's the combination reaction. So two compounds or three compounds become one compound. Always in the right side is gonna be one compound. So what about single replacement reaction? Single replacement reaction are always redox reactions. So just know this basically. Know that if you have a single replacement, it's gonna be redox. If you go to higher level of chemistry, they tell you more about redox reactions. So what is redox, guys? In redox reaction, you have one element alone, and you have a compound. You have one element alone and you have a compound, which is cation and anion. In the right side, the cations switch basically. Basically, the metal or this single element replaces with here B. So you see that in the right side, B is alone now. And the A is going to be combined with AX. So this B is going to be replaced by A. Okay? In the right side of reaction. Example of single replacement, make sure always left side is a single element. Zinc. Another thing, guys, when you see an element which is single, always put S or solid. So if you see a single element, always put, they are always solid single elements. Then when they combine with the compound, which is had cation and has cation and anion, then this Cu switches with zinc. So Cu here gonna be alone and zinc gonna be with oxygen, zinc oxide. This is the example of single replacement. Another name of single replacement is single displacement. Let's see how we can know that a single displacement reaction happens. Not always we have a single displacement or replacement reaction happens. When we can say it happens, we have this reactivity series of metals table. This is called reactivity series of metals. What does it mean? In this table, the most active metals or the most reactive metals are in the arrow in the top of this table, in the top arrow. When the arrow goes to the basically arrow goes to the top, these elements are more reactive, but when the arrow is down, these elements are less reactive. You can see in the right side of them. The elements in the bottom are least reactive and the elements in the top are most reactive. What does it mean, guys? It means that potassium or metals in group 1A and 2A, you can see that potassium, sodium, calcium, magnesium, even aluminum are from group 1A, 2A, and 3A, right? These are most reactive than the other elements, right? Like transition metals. So these are really, they want to be activated. They want to be react with other elements, you know? So in here, how we can use it, guys? When you see a reaction like this, how you can complete it? Can you just switch this, as I said, like if you want to find a product here, I just told you this Cu here basically gonna replace with zinc, right? That's what I said. But is it always happening? No. we should make sure when it is happening, always the most reactive metal should be alone. When the single displacement happens, always the most reactive elements always is alone. Here, let's see. Let's compare zinc with copper here. Always make sure to compare the metals or compare the positive ions, okay? Compare the positive ions. I compare the zinc here with copper. Which one is in the top part of the table? Zinc is here, right? I'm arrowing to, right? Is zinc. Where is copper, guys? It's here. Which one is the higher one? Zinc, right? Compared to copper. Zinc is alone. We said that if the more reactive elements should be alone. Zinc is more reactive because it is in the top part of the table compared to the copper. When I switch them, this is the product, guys. We said that when you have a single element, you put S, and here we said that based on the solubility table or solubility rules, we said that most of the oxides are insoluble. So ZnO is going to be solid. Okay, guys, which of the following reactions are happening? Let's see. Please pause here and see if we can do them. Okay, I have Ag. I said we should look at the metals here or positive charges. Ag and Al. Let's go back to the table. Ag, where is Ag? Ag is here. Where is Al? Al is higher, right? Which one is alone? Al is alone, right? So do you think it's happening or not? It's happening because Al is single and is the most reactive element. So here the reaction happens. So I'm going to write the product. I'm going to later talk about more about predicting the product. Please bear with me. I will tell you how really this subscript come from. It's basically coming from nomenclature. If you are good in nomenclature, you should be able to write the product. But I will talk about in later how to predict the product in more detail. So what about Pb and Mg? Look at the cations, guys. Pb and Mg. Let's see if the alone element is higher or not. I have Pb and Mg. Which one is higher? Mg. Okay, Mg is higher. So the most reactive is Mg. Is Mg alone? No. Mg is not alone. So is no reaction happens here because the most reactive element should be alone to reaction happens. Okay, what about Fe and hydrogen? Because the cation here is hydrogen and Fe. Look at hydrogen and Fe. Hydrogen is here and iron is here. Which one is more reactive? Fe. Is iron alone? Yes, is alone. So the reaction is happening. Okay, guys, let's continue with double displacement or double replacement reaction. Just know that double replacement are never redox reactions. This would be enough for now. Okay, I talked about the single. Let's talk about double displacement. How they happen. In double, we have two compounds. Each have their own cation and anion. And in them, the cation switch. So A is gonna switch with B. A switch with B or X switch with Y. So, okay, A switch with B or cation switch or anion switch. Doesn't matter, one of the other one should switch. So never ever try to switch both of them at the same time, because you're gonna have the same compound at the end, right? So cations are switched, so A and B are gonna switch, or X and Y are gonna switch. So we're gonna have here, if I change the A and B, is gonna be what? B is gonna replace with A, right? Is going to be Bx plus Ay. Let's do in the real reaction. So I have cation Ba. What is anion here? Nitrate, right? What about here sodium? Is cation. What about sulfur? Is anion, right? So we switch the cations. Na switches with Ba, and it's going to be the product. This is called what? Double displacement reaction or double replacement reaction.